security. Worried about the reliability and performance. Hi, and welcome to Module 2. Here we're going to do a basic introduction to DevSecOps, kind of what it looks like, what it consists of, what are the principles, what are the players in it, etc. So our learning objectives. Our first one is addressing DevOps process security bottlenecks and challenges. The second learning objective is to understand DevSecOps. In Lesson 3, we'll understand the DevSecOps culture. In 4, we'll understand continuous security in DevSecOps. In 4, we'll understand the DevSecOps pipeline. In 6, we'll look at the DevSecOps strategy. And then in 7, we'll briefly go over some of the DevSecOps tools. So let's start with Lesson 1, addressing DevOps process security bottlenecks and challenges. Conventionally, security checks are performed at the end of the software development lifecycle, after the development of the product. This is what's been historically one of the main problems with security. Fixing an identified security issue at the end requires rework. It's time-consuming. Instead of checking security at the end after every new feature is developed or an application in and of itself and released in production, we want to perform security testing at every phase and resolve security issues as soon as they appear. So down below you see security testing at every phase instead of just at the end of the standard DevOps kind of pipeline. We're going to introduce things up earlier with developers, insert security tests, cloud, automated tests, security tests with builds, deploys, and advanced testing once we have things up in the production environment and running. We want to fix DevOps security bottlenecks by shifting security to the left. Now, shifting to the left just means that we're going to introduce security earlier in a process. To implement secure DevOps, developers, operations, and security professionals have to work together throughout the development lifecycle. The days of throwing requirements over the wall and seeing later if they were done is kind of over. The security team should advise the development and operations teams to help them understand and manage security. The security team should also be involved in creating security policies, choosing automation tools to identify security issues, and training the development and operations teams in interpreting the output from those tools so they can identify and fix the issues by themselves. So on the right, the self-sufficiency kind of kicks in. Developers are also responsible for security, and the security team advises the development and operations teams. Addressing DevOps security challenges. You have to strengthen the DevOps security model by implementing the following. To minimize the risks arising from manual errors and potential vulnerabilities, you leverage automation. It helps in developing secure applications with speed and scalability. You manage vulnerabilities effectively and efficiently by using a robust vulnerability management system. You enforce robust DevOps management solutions, such as Azure Key Vault, AWS Secrets Manager, and CyberArk. You implement effective privileged access management solutions to minimize the risk from internal and external threats. You find and remove open source code vulnerabilities. You centralize an effective and efficient auditing and logging system. You detect vulnerabilities present in base images and perform remediation when discovered. You design secure, immutable infrastructure. You perform continuous assessments to identify and remediate security issues. You integrate security tools into the DevOps pipeline. You use configuration management within infrastructure as code for implementing security as code. So let's start to try to understand what DevSecOps looks like in this next lesson. What is DevSecOps? Basically, it's the integration of security practices into the software model of DevOps. With DevSecOps, everyone is responsible for security in the entire model. The goal of DevSecOps is to incorporate security in all phases of the software development lifecycle by integrating security through tools, encouraging cross skills, and establishing security as code culture. On the right, you can see the SecDevOps kind of interplay between development, who have software releases and updates to do, and security, who's worried about confidentiality, integrity, and availability, and operations, who's worried about the reliability and performance and scaling of their systems. And we run into that and we look at skills and culture and tools to create this integrated DevSecOps type of an environment and operation. We kind of have a DevSecOps manifesto. These are the things that we want to try to get beyond the old way of doing things and step into the new with DevSecOps. So one of the first pieces that we really want to kind of focus on is leaning in. You want to overcome the urge to always decline requests or to build walls between yourself and operations and developers. The whole thing about DevSecOps is that you're an integrated kind of a cross-blended function rather than just towers of knowledge and expertise. You want to be able to use data and security science and overcome fear, uncertainty, and doubt. Look at what's really in front of you and what you're trying to accomplish. You want to create open contribution and collaboration, and kind of get away from the security-only requirements. Think of security in terms of business needs, of developer or environmental constraints, etc. What do we do instead? How do we work through things? You want to have consumable security services with the APIs and things like that, and overcome mandated controls and excessive paperwork. You want to have business-driven security scores, and kind of overcome the urge to rubber stamp something as security checked that it's okay. With a continuous long cycle security involvement, get into metrics that can actually drive improvement and efficiencies. Red and blue team exploit testing. You want to overcome reliance on just scans or theoretical vulnerabilities. Actually do some live testing of what you have going on, interactive testing even. Look at 24/7 proactive security monitoring as the solution. Get away from the reactive discover and response model that you're working in. Shared threat intelligence. Overcome the urge to avoid sharing of information with threats, vulnerabilities, things that are going on in the security world with the rest of the DevOps team. And last, compliance operations. You want to overcome clipboards and checklists and get things built into your processes that actually address your compliance concerns and issues. So DevSecOps is really a mindset rather than a collection of rules and tools. To the organizations that have been practicing DevOps, it's a different way of thinking about security. The distinguished features of DevSecOps includes open collaboration on shared objectives. We look at security at the source, where the code starts. We want to be able to automate repetitive tasks and have a risk-oriented operation and actionable insights that come out of this effort. With our DevSecOps kind of mind frame, how we look at things, we want a holistic approach to our security objectives instead of just, point shoot type of solutions. You want to have proactive monitoring and recursive feedback throughout this entire cycle. As much as possible, automate operations with security. There's been a lot of talk about SOAR and things like that lately, but DevSecOps actually gives us the opportunity to automate our security functions now pretty efficiently within this realm of the operation. Then you have operations engineering that we want to focus on, which is how do we build up the environments, how things are accomplished and done. There are common misconceptions and misinterpretations regarding DevSecOps. People have the wrong idea about what's going on with DevSecOps, why it's too difficult to do or why we should maybe not do it. One of them is that DevSecOps is only security as code as part of the automation. And that's absolutely not true. It actually incorporates a little bit more than that, as we'll see later on. Possibly that DevSecOps is incompatible with compliance requirements. Of course it's not. That's part of the reason that you're implementing, in fact. The security team does not require development knowledge. Also false. If you're in a SaaS shop or a high development environment, you really should know something about how development works. DevSecOps requires developers to be security experts. It doesn't. One thing I've seen deployed successfully is you put a security expert maybe within one of those towers we were talking about, a functionality that's being delivered constantly, but you don't require each developer to be a security expert by any means. DevSecOps simply means code scanning. It doesn't. It's a lot more interactive than that, with all of the insertion of events and approvals and things like that, and the testing that goes on. It's goes much more beyond code scanning. We're talking about environments and templates and baselines, as well as other types of analysis that we do. DevSecOps requires significant tool investment. It doesn't. There are certain tools that you'll find that are fairly inexpensive and robust, where you only need a handful to be able to successfully implement what you need within your environment. DevSecOps prevents organizations from meeting their business objectives. And of course it doesn't. It actually helps to accelerate you into the marketplace not only quicker, but more securely. There are a lot of benefits to DevSecOps. First of all, it reduces security vulnerabilities in applications. This is started at the very outset of development of an application or updating it. Compliance can be incorporated into the pipeline at the initial stages, so you don't miss critical compliance requirements. Developers can respond to code changes very, very quickly. DevSecOps helps in the early identification of vulnerabilities and allows the security teams to work faster towards taking care of issues within the environment. With a properly implemented DevSecOps, every change can be tracked and monitored so that you have that record of what happened. It builds a faithful relationship within the organization between security and operations and development. It reduces cost and helps in a faster delivery of software, certainly. SecDevOps offers transparency in the early stages of development. It is secure by design with increased observability and traceability. So at the very outset, everybody can see what's being done and who's doing what. It provides security, monitors resources, and sends notifications much earlier in the stages if properly implemented. Since you're doing this level of security implementation within the environment, knowing changes, seeing the code, et cetera, you can recover from security incidents much faster. And it improves overall security with immutable infrastructure. We were talking about infrastructure as code in particular. With the fast pace of blowing up and bringing down systems in a cloud architecture, et cetera, you have a much higher assurance of those environments being secure with a DevSecOps approach. On the right, you can see the benefits of DevSecOps. In the plan, you have the policies and you do some threat modeling. In the coding side, you do static analysis, code reviews in the build. In the testing, you do penetration testing, et cetera. Compliance validation during the release. In the deployment, you collect logs and you run audits. During the operation of it, you collect threat intelligence. You do live monitoring of the applications in the environment to detect and respond and recover. And then you monitor how well things are doing, and you come back into that continuous loop of planning for the next release. Steps in the DevSecOps pipeline. Security checks are performed at every stage pretty much when you have a fully implemented DevSecOps model. The following steps for security testing are followed in an organization that has pretty much fully embraced DevSecOps. In the plan stage, you execute security analysis and develop a plan to determine the scenarios for when, how, and where the security testing will be performed within that cycle. Within the code, you protect API keys, passwords, and other secrets by implementing Git controls or through the use of linting tools. Linting tools are, think of a lint roller. They're real quick security scans that pick up obvious errors and problems with code. During the build, after you build the code, these static analysis tools are used to identify security issues in the code before deploying to production. When testing, to test an application during runtime, you could use the dynamic application testing tools to identify errors related to authentication, authorization, issues with SQL injection, etc. Upon release of the code, you use security analysis tools to perform penetration testing and vulnerability scanning before releasing the application. And of course, once it's released, you have deployment. Once all these tests are completed at runtime, the secure build or infrastructure can be sent to production for deployment with a fairly high assurance that what you have is secure and safe. So I know it's a little bit repetitive, but let's talk about DevSecOps pillars. And they're basically pillars or the main big pieces or thoughts as to why we do this. Why do we do DevSecOps? Number one, collective responsibility. Security is the responsibility of the entire DevSecOps team. It doesn't reside on security just throwing requirements and policies and things like that over a fence and telling everybody to make sure they do it. There's collaboration and integration. Communication and collaboration plays a significant role in making DevOps central for building software products. There's pragmatic implementation. You have a holistic view of the software development lifecycle and the security based in it. And based on this view, you should select a platform that provides robust integration capabilities or integrability. Number four, bridging compliance and development. To bridge the gap between compliance and development, determine the applicable controls that you need, translate them into suitable software measures, and determine the inflection point in the software development cycle of where this is going to be inserted and tested. Automation is a main pillar of DevSecOps. Automated security enhances the efficiency and minimizes workloads and assures that you have these regular checks for quality performed at regular intervals. You have the ability to measure, monitor, report, and act. For successful DevOps implementation, results obtained at the time of application development and release should be measured, monitored, and reported, and appropriate action should be immediately initiated if problems are observed. So it gives you the ability to do this. These are the 6 main points of why we do this. There are these areas for a successful DevOps project, the 4 main things that are going to influence how well you do. DevSecOps practice in an organization starts with the support of senior leadership for the DevSecOps philosophy, leading in a cultural shift in the organization, development of new collaborative processes, integration of technologies that can automate processes, and the application of consistent governance. So within the organization, you have this cultural buy-in that has to happen in collaboration and communication. You want to make sure that everyone understands they have responsibility for quality assurance throughout. You learn from successes or failures instead of just, like the old axiom goes, instead of just assigning blame, you actually fix problems by looking at success and failure and get feedback that way. And changes are made by the users. As far as process goes, we look at collaborative software design, software development based on testing, the automation of common tasks, continuous adaptation of the environment to the requirements of security or the application or whatever. But you look for a constantly adapting environment and a continuously improving one. And you have a continuous authority to operate and move forward throughout the processes. With the technologies, you look for tool automation, orchestration, being able to bring these tools into collaboration with each other so they work to give you the desired result. Containerization of your environments so that you restrict down what's being done by what, which kind of leads into infrastructure as code and security as code. And last of all, governance. With DevSecOps, you'll have uniform policy enforcement throughout and built-in governance and controls. You use validation using data and metrics instead of just guessing at it. You have improved visibility and using inherited certifications across for securing your secrets and operations and things. What are the metrics for measuring if you're successful at this? In DevSecOps, it's not sufficient to measure software development delivery performance on tempo and stability metrics. They cannot provide sufficient security, and in fact, it can lead to the accumulation of security issues. To measure success in the implementation of DevSecOps, the U.S. General Service Administrator, or GSA, has introduced the following high-value DevSecOps metrics. So here's how we measure if security is properly implemented and if this is working well, the DevSecOps program. The first is deployment frequency. This metric tracks the frequency of deployments to production within a specific time frame. The next one is change lead time for applications. It measures the time between a code commit and it hitting production. Code change volume for applications measures the number of user stories that are deployed in a given period. Failure rate. This is the percentage of failed production deployments, another great metric. And then we have MTTR, or mean time to repair, for applications. And this measures the time between a failed production deployment and the complete restoration of the production environment in operations. Availability, of course, measures the uptime or downtime in a particular time frame as per the service level agreement or whatever you've deemed to be the success target of what you built. Customer issue volume. This can be a little bit misleading sometimes if you're bringing in customers, losing old customers, or if it's a dynamic environment. But basically, it measures the number of issues reported by customers within a given period and what's happening to that with increases or decreases. Customer issue resolution time. This is a metric that shows the time taken to resolve an issue reported by a customer. Now, of course, some will be more difficult than others and it'll take longer, but it's still a good metric. Time to value measures the time between a request for a feature and the recognition of business value from that feature. You do this when you actually start seeing business benefit from it. What about the time for authorization to operate? So you start this little sprint or this development cycle. What does it look like from day one to where the thing is authorized to operate? And then the time to patch vulnerabilities. And this is a difficult one sometimes with organizations because patch management is a tough security issue. But basically, this is the time taken from the detection of a vulnerability in an application or platform to the successful deployment of a patch in production. So anyways, here's some metrics that are very, very valuable as far as being able to be used within to determine if your DevSecOps is a successful operation or not. Now, what about the challenges and mitigation that we have? Shifting from DevOps to DevSecOps poses a lot of challenges for developers. Some of the key DevSecOps challenges and their mitigation steps for these developers are as follows. A developer knowledge gap related to secure coding practices is an obstacle for shifting the security to the left. And the mitigation for that is provide formal AppSec training and e-learning with self-paced micro courses. Furthermore, you can mentor and assist the developers with secure development practices and remediation activities. Another challenge that we have is various application security tools provided by different vendors are integrated into the DevSecOps pipeline. These securities are difficult to use and manage, and they cannot provide a single consolidated view of security issues. The mitigation for this is to find that single security tool that satisfies your security needs. It's the best option for mitigation. You're going to have more than one security tool in there. Just try to minimize them as much as possible. Find a tool that does a function well for you, such as SAST or DAST or RAST, and lock onto it and use it. May not be the best in all scenarios, but try to minimize a broad use of a lot of different tools. Another challenge, most application security tools were designed in a manner that requires a high level of human intervention to resolve security issues, which puts pressure on developers, or even to run the tool. But anyways, what you want to do is implement tools that work automatically and trigger tests based on the events of the software development lifecycle so that the developer can focus on major security risks. And not only that, but with the advice out of the tool as far as how to mitigate, how to take care of that security risk in such a manner that they can get to it more rapidly and early in the stages. So who are the stakeholders when we talk about having a DevSecOps function up and running in an organization? The DevSecOps technology stakeholders in an organization are primarily the Chief Information Officer, the Engineering VP, and the Chief Technology Officer. They represent the culture and future requirements of the organization. From the security side, you have the Chief Information Security Officer or Chief Security Officer as the stakeholder. Their focus is on the security posture of build environments, software supply chain, etc. Then you have the business stakeholders. The business stakeholders include sales, marketing, finance, and legal teams. These business units should work together with the technology team so that the organization can control the maximum possible benefits from the DevSecOps practices. And they'll be involved in a lot of discussions as far as requirements from a compliance perspective, customer perspective, business perspective, etc. There are certain key behaviors that you want in a DevSecOps program. The key security behaviors that an organization should instill into the DevSecOps teams are as follows. Number one is threat modeling. Security behavior is to think like an attacker and estimate the security impact of each design that's been implemented. The desired outcome is to implement a design that protects the confidentiality and integrity of data. Security code reviews is another big behavior that we want instilled here. Identify security issues in other developers' code is one way of doing this. Identify the errors in code that can be exploited in a shared environment. Red teaming is another behavior. And here you could execute an attack on the code by acting like an attacker in the period from deployment to production. Desired outcome here is to detect bugs and security issues by active testing. Then you fix them and quickly push the remediated code to the next stage or even production. All right, so let's get into lesson 3 and understand the DevSecOps culture. Basically, the DevSecOps culture is a culture that incorporates security best practices in the DevOps pipeline and holds everyone accountable for the security of an application or whatever's being built and deployed. The main aim of DevSecOps culture is to unite the security operations and development teams and develop a shared responsibility type of a framework. Within the culture, you have 4 basic pieces: governance, process, technology, and people. So if we look at people, all the teams should communicate well to ensure early feedback on quality to reduce the cost of implementing changes later. This is a little repetitive, but it's worth repeating. Governance in SecDevOps culture should create comprehensive metrics and ensure that the best practices are followed. Processes, we look for commonly agreed upon processes to be followed while shifting to that DevSecOps culture to improve security. And last, there's technology to be employed to implement new DevSecOps processes such as automation, security as code, and configuration management. So let's talk about the people piece of it first. The DevSecOps culture should unite all teams and make them work towards a common goal of faster delivery of software that's secure and stable. To achieve this goal, the following can be helpful, and these are just some ideas. One is to create a security program champion. A champion is usually placed in this development team to ensure that security is the main goal of the entire software delivery process, and they communicate security requirements to that entire team. You can train the teams. Train the existing development team and new recruits about practical hacking exercises, threat modeling, etc. The entire organization should be actually trained to ensure that each phase of the business is secure. But getting back to this, you can use things like the OWASP 10 training or whatever. Build empathy and cooperation. You build empathy between teams by making security team members possibly work in development teams and by assigning developers to work with security teams for certain periods of time. It doesn't have to be for a protracted period, but this helps the teams to understand the inner working and challenges faced by other teams and what their daily lives kind of look like. Think of it as implementing cross skills kind of training. And of course, the last one is to reward employees. Another example, gift cards to motivate them to deliver strong results or to achieve the goals that were set out for them. When we look at the DevSecOps culture from a process perspective, common processes have to be used that are accepted by everyone. And they should not create any hurdles for the high-end deployment environment that you've built. Processes implemented throughout the pipeline play a major role for establishing collaboration between teams and achieving all of your objectives. You can use threat modeling. It evaluates the planned software to determine issues that may occur when an attacker targets the software. It is time-consuming and resource-intensive. Hence, in the DevSecOps environment, use a streamlined approach in which new features of the software can be added to the backlog through user stories. These user stories allow a clear idea of what's being developed next, and a quicker threat modeling exercise can be achieved out of that. It also helps teams to understand their roles and objectives. Threat modeling can be leveraged to create that more collaborative environment. Let's talk about version control and orchestration. Every action implemented in DevSecOps has to be assigned a version to track all the changes and to be able to recover quickly if something goes sideways. Orchestration tools can provide a large amount of metadata that can be used as a source for tools integration, a source of knowledge. The coupling of orchestration software with versioning is a great source for data for the operations team, not only when it comes down to information about where you're at within builds, etc., but also to be able to provide faster integrations or a clearer idea of the metrics and what's going on inside. Let's continue on. What do we do about compliance with process? Basically, you create metadata describing the compliance requirements and integrate them with the organization's assets. This can, in turn, enable security to respond to threats within required clips or timeframes, such as the 72 hours of response to a threat per the GDPR rules. Security architecture. Every organization has certain principles to support secure architecture based on the data that it processes. A lot of times we try to associate security tags or simple controls based off of the criticality of data and systems. Organizations using a DevSecOps model should ensure that the processes are implemented to update the architecture continuously. For incident management, typically you have action plans, workflows, runbooks, and playbooks that are created in advance of an incident so you can respond in a repeatable and consistent manner. If we look at that in a DevOps program, there should be a level of abstraction for incident response processes built within DevSecOps to ensure that all the incidents are handled in the same framework as far as what could happen within that environment. The playbooks can be automated and integrated into these into the processes. The continuous integration, continuous development pipeline once they're codified. What about proactive security assessments? We know that most organizations, or everyone that I'm aware of, requires active vulnerability identification, irrespective of how advanced it is in perspective to DevSecOps. The following are some of the methods for vulnerability identification. There's penetration testing that focuses on determining areas where an application is vulnerable to attacks. Red teaming follows an attacker approach to determine how different vulnerabilities can be used, possibly cohesively, to launch an attack. Then there are bug bounty programs that allow outside parties to discover and report vulnerabilities in the software, and then your organization rewards them for doing so. Another source of process that should be integrated is threat intelligence. Threat intelligence is the information used by an organization to determine existing or new threats that target the enterprise. Organizations that adopt DevSecOps can use threat intelligence to handle process flow and recommendations for remediation. Basically, threat intel is sourced from outside your organization. It can come from anywhere, such as websites, vendors, software vendors, government organizations, etc. It's you keeping your finger on the pulse of what's happening in the security world outside of your organization. The next piece of the culture, technology. Technology enables teams to effectively implement development, security, and operation processes in the DevSecOps pipeline. The following technologies can be used by an organization for effectively implementing the DevSecOps culture. Source code repositories. This is the main technology in which other technologies used in the DevSecOps pipeline can be integrated. It can be used to store project files, web pages, and patches, and can be accessed either publicly or privately. So think of the source code repository or library as the heartbeat of this whole program when it comes down to the technology. Configuration management. Automating configuration management and integrating it into the development cycle ensures proper tracking and easy reporting of changes. Orchestration. There are various solutions for orchestrating the deployment of infrastructure. Container orchestration, such as Kubernetes, can be used to implement and manage repeatable security best practices. You do this through container templates and things like that. Host hardening. You can implement host hardening in DevSecOps as automation. It reduces attacks on applications as it removes unnecessary applications, disables irrelevant accounts on the system, etc. You can close off unnecessary communications channels, all kinds of things through hardening. Securing Docker images. It's important to follow best practices to secure Docker images, such as avoiding unnecessary user privileges, signing images digitally, and using the Docker secret feature. Continuous integration, continuous development for patching. The metadata linked with each asset can be used to implement patches for security vulnerabilities at the CI/CD level. Continuing on, we could use secure coding standards. Coding standards continually change, and code should be checked with updated security recommendations. Code changes must be validated and tested against new recommendations. You can use application-level assessments. In DevSecOps, it's important to assess the application-level security to determine the risk posture and mitigate vulnerabilities before an attack occurs. The following can be used to improve the security posture. You can use source code scanning that can be performed using static application security testing tools to identify security vulnerabilities within the code. You can also go dynamic. You could scan a website at runtime and analyze inputs, forms to identify vulnerabilities. You can integrate SAST with IDE with your integrated development environment and allow developers to receive a notification when insecurity practices are followed. This helps mitigate vulnerabilities very quickly and very early in the coding stage. You can use binary scanning, and it has to be performed to find security issues from a coding checklist, which is then signed digitally to ensure the security. This is where we come up with digitally signed code, is through binary scanning. Then you have pre-deployment auditing. To ensure security in a DevSecOps pipeline, you can use a predefined template to deploy resources. And then, of course, there's post-deployment auditing. After instantiating predefined templates, you verify them to check for any difference from the pre-deployment scans that may cause security threats. Technology continued again. Automated vulnerability management should be integrated into the infrastructure scanning platforms to track all the identified vulnerabilities. Automated compliance scans or automated security configuration assessments can be used to reduce the compliance cost. It also allows sharing of the compliance information with the GRC tools, which is your governance, risk, and compliance tools up in the security function, typically. Secrets management. Secrets can be the source of a breach, therefore they should be secured. With the use of an auto-generated secret store, the entities for temporary usage should have less time to live, or TTL. Secrets, certificates, digital signatures, things like that are all considered secrets, as are user credentials, user IDs, passwords, whatever. So anyways, that's when you hear secrets management, that's what we're talking about. Now let's talk about governance within the DevSecOps culture. When an organization makes a cultural shift, it should be able to monitor the progress, measure its success, and should know the challenges that it's facing as it does this. Governance functions ensure that best practices are followed and the expected outcomes are achieved. In DevSecOps, governance should build a comprehensive metrics program. DevSecOps should focus on the continuous development of the culture, and the metrics in the governance should demonstrate this, that you've hit this cycle within your organization. Best practices for DevSecOps include the following. Train developers on secure coding. Train development teams on secure coding practices, as they may not be aware of what insecure coding really looks like. Automation. Automation plays a key role in the success of DevSecOps. Auditing becomes easier with automation using metadata. Proper tool selection. The tools used in the DevSecOps pipeline should make the software delivery process fast and produce accurate and actionable results. Threat modeling helps understand the existing and emerging threats to resources, as well as the security controls required to safeguard the resources. Compliance implementation, you can create metadata to describe the compliance requirements, which can be integrated into the assets. Incident management, we talked about it. To respond to incidents in a measurable and consistent manner, action plans and runbooks should be created in advance. Secrets management. Secrets such as your credentials and keys should be generated for temporary use only, and the authentication mechanisms should be different for each environment. Pre-deployment and post-deployment auditing. To ensure that the proper required security level has been achieved, pre-deployment auditing should use predefined templates for creating resources. Post-deployment auditing ensures that the security level gained through pre-deployment auditing is valid and that it worked properly. In Lesson 4, we'll go through understanding continuous security in DevSecOps. In continuous security, security is an integral part of the CI/CD pipeline to develop secure applications. Continuous security works along with other continuous development processes and makes the product and infrastructure more secure. Continuous security should be a core implementation for the DevOps pipeline as more frequent application changes and releases occur. It helps in mitigating most of the security issues before the product release. It can be implemented into the existing DevOps pipeline by making changes while keeping application security in mind. Continuous security facilitates the proper management of security alerts for security incidents by setting metrics on applications and infrastructure. And finally, with continuous security, potential attack vectors can be identified and fixed by automating the remediation process. Implementing continuous security provides the confidentiality, integrity, and availability traits for the pipeline. 3 elements are important in establishing continuous security in the pipeline. We have culture, infrastructure, and software delivery. With culture, security should be the central focus of an organization's culture. Infrastructure should be implemented with the recommended security best practices. And finally, software delivery is the process of software delivery, and it should be focused entirely on security, or not entirely, but in our field, we see it as it should be. Of course, they have their business that they have to support, but there should be that security focus. There's three principles of continuous security that should be considered. The shift left idea. And basically, that's kind of a buzzword for moving yourself earlier into a process. By implementing the shift left principle, bugs can be fixed at an early stage of SDLC, which saves time and cost in the SDLC program. Automation. The chance of errors in repetitive tasks can be reduced by implementing automation. It can also reduce time and improve productivity. And finally, continuous improvement. The continuous improvement of security is required for better overall security. It can be achieved by analyzing the current behaviors and searching for possibilities of improvement. Metrics can be looked at as well as the overall results of what's being produced. Continuous testing can be successfully adopted into the continuous integration, continuous development pipeline by performing automated testing. We have a testing pyramid that basically the testing automation kind of follows along with as we implement it. It provides an overview of the complete testing process, starting from the small unit testing to a complete connected process. The first is level 1. This is the base of the pyramid and involves unit testing, which uses the white box method. Here, unit tests are performed on small pieces or individual units of code in the software. And white box means that the internal workings of what you're testing is available to you. So you actually see what's being performed in that code very, very clearly. On level 2, we have an integration testing. And code units are tested in terms of how they interact with each other, which involves a chain of components. And finally, we have level 3, which is black box testing. This is used for end-to-end testing. The scope of testing depends on the process. It is performed to test the workflow from the user's perspective. And the reason we call it black box is because you're not necessarily looking at how individual units perform. You're looking at the overall result from the start of the chain to the end of it. The following are testing terms other than those mentioned in the pyramid. We have functional testing. The function of the application is tested to determine whether it satisfies the specific requirement from the end user perspective. Regression testing ensures that old features are working as intended, even after adding new features and frequent updates. Regression testing increases as changes to an application increase. Load testing tests the behavior of the software under high input or stressful conditions. API testing. The program interfaces are exposed to third-party developers typically and should be tested in terms of expectations for functionality, performance, reliability, and security. This is typically performed as black box testing. And then there's the user interface testing. UI testing is performed using automated tools that mimic the actions performed by users. Continuous application security testing. Let's talk about the four kind of big chunks of this. DevSecOps provides continuous security with continuous integration and development. Application security is a type of security in DevSecOps, in addition to infrastructure security and pipeline security. So think of it as you have infrastructure and the pipeline itself. How secure is it in moving code, et cetera, and interacting with external websites. Application security starts when the developer starts developing code and lasts for as long as the application is used. Various types of application tests are performed in DevSecOps, such as static, dynamic, source code analysis, interactive, and runtime application secure. You're looking at the performance of what's going on in there. These are all integrated into the DevSecOps pipeline for continuous testing. So with development, we have code quality, static testing, and thread modeling. In the integration phase, we have repository scans that occur with the library. We have code quality reviews with SCA. We use some static testing here. And we also do image scanning. In pre-prod, we'll still do some static testing. We'll get into dynamic testing, seeing how the application functions as it runs. Integrated testing, how it runs in an integrated environment, and also penetration testing. In production, we typically use dynamic and integrated testing and also runtime testing, which is RASP. So we have static code analyzers. Static code analyzers can also be called linters. These tools are added to the ID environments as extensions to identify and fix the quality issues of the code. They help detect vulnerabilities such as the OWASP Top 10. SCA tools help in maintaining code quality and consistency. So linters are basically scanners that find the easy stuff that you can kind of pluck off, or lint roll, I guess, is where we come up with the term linters. Then we have static application security testing. Testing applications with SAST ensures that the code follows best practices when it is developed. SAST is also called white box testing because we actually see the application. It's open to us. We see what's inside and how it functions. SAST scans for vulnerabilities, identifies them, and helps in mitigating them. Typically, you have recommendations that come out of your SAST tools. Then we have the software composition analysis tools. Software composition analysis tools stand for vulnerabilities in libraries and dependencies of the application. SCA tools identify the open source components of the application and align them with community databases and issue trackers to track vulnerabilities. We have dynamic application security testing. Dynamic application security can be integrated into the DevOps pipeline once the application is deployed. DAST is also called black box testing. It analyzes and finds vulnerabilities in running applications based on the request and response model. And again, we're not looking at the inside of the workings, we're looking at the results. DAST finds vulnerabilities by detecting the patterns that indicate security vulnerabilities. It does not have access to that code. Again, hence the black box term. Then we have IAST, or interactive application security testing. IAST is a combination of SAST and DAST techniques. IAST can detect vulnerabilities before the application can be exploited. It is also known as gray box testing because we know a little bit about the outside with the static side, and the dynamic side kind of gives us that black box test. Basically, IAST detects the vulnerabilities in an interactive manner by interacting with the application. The IAST agent is integrated with the application and monitors the application logic flows, data flows, and configurations to find vulnerabilities. And then finally, we have the runtime application self-protection. RASP is injected into the application or its runtime environment, think in production, basically, and monitors the security of the application from there. It can also control the application execution. It intercepts every call from the application to the system and checks whether they're secure. If an attack occurs, RASP has the ability to terminate the session and alerts the defenders, your security team, that something bad has happened. Implementing security as code. So kind of think of us as interleaved into this process of DevSecOps and the fact that they do their plan, their code, their build, and we embed code analysis testing in the code for quality assurance. We also automate controls and security validation in the CI/CD pipelines by using workflow generators and things like that. Then we get into the test release side, and we automate controls and security validation in the operating environments. And then as we deploy and operate, we add operation-centric controls. Let's get into Lesson 5, Understanding the DevSecOps Pipeline. Let's talk about the role of DevSecOps in the CI/CD pipeline. DevSecOps is a culture that automates the implementation of security in all phases of the software development lifecycle, from design to software delivery. Continuous delivery and continuous integration allows developers to validate and report every code commit in the software product. When automated security with DevSecOps is integrated into the CI/CD pipeline, The DevSecOps team can identify security warnings at early stages and monitor vulnerabilities that may occur in the subsequent stages. Typically, they're put into a workflow at that point to be remediated, or you carry forward what's called a technical debt, which we'll get into in a little bit, or security debt. Let's talk about the tool chain. A DevSecOps tool chain consists of tools that can be used for the successful deployment, management, and delivery of applications through the software delivery process. A DevSecOps toolchain is built on top of a DevOps toolchain. Upgrading to the DevSecOps toolchain enhances application security. The toolchain defined by Gartner includes the following steps: plan, create, verify, pre-production, release, prevent, detect, respond, predict, and adapt. And so let's look at the graphic a little bit here. In the plan side, we address technical security debt, which means known security issues that were carried forward from the last release. We also we look at the DevSec metrics, threat modeling, and security tool training. Then we get into the create side, and this is where we do the integrated development environment security plugins. As we get into the verify of what's being created, we implement SAST, DAST, IAST, and SCA. In the pre-prod environment, we look at trying to do some integration testing and some user interface testing, even using Chaos Monkey input and fuzzing. We have the release, which gets into the signature, the software signing. On the prevention side, so we have the code released, we verify the signature, we do integrity checks, and we look at our defense in depth measures. Think about web application firewalls, changing any SIM configurations, multi-factor implementation assurances. So what you're looking at is your defense in depth is all of these measures that you're applying to the environment. You're kind of going through those. Then we go out into the detect side, and we look at RASP, user and entity behavior analytics, which is kind of like almost your endpoint kind of monitoring, network monitoring, and penetration testing. In here, we look at log and parameter monitoring and RASP feedback. We have the code up in production, and now we're wanting to know how it's performing in runtime or real time. We have the API gateway security and performance logs that we look at. Then we have the respond side of this if something happens that's bad. We look at security orchestration, RASP and WAF, shielding, obfuscation, as well as our run-in playbooks. Then we start getting into the predictive phase of this, and we look at development consumables, creating vulnerability analysis, IOCs, which are indicators of compromise, using STIX or TAXI. STIX or TAXI, real quick. STIX is the structured threat and information expression. It's a standard XML kind of programming language for conveying information about security threats in a common language that's used across a lot of different pieces of the technical landscape out there. And then TAXI is the trusted automated exchange of intelligence information. And it defines how cyber information can be shared across and messaged through exchanges. So then we get up into the adapt, which is security technical debt is looked at again, modify our incident response, and modify D&D. And at that point, we start the plan over again. So you can see that we work through this entire cycle from a 0 point to a fairly mature point where we can predict and adapt what we need to do to protect the environment. Embracing the DevSecOps cycle. By embracing the DevSecOps cycle, organizations can infuse security during the early stages of application development, decrease the remediation time, and develop safe and secure software products very quickly. The DevSecOps cycle reduces the gap between the developers and the operation team as the entire team takes the responsibility of application security. And here's another little cycle that we look at. We talked about this in the last one. I won't go into it a lot, but we start down at the predict stage. If we do X, will it mitigate Y? We're trying to get a little bit predictive with some threat modeling, things like that as we predict and plan We analyze and predict the security backlog. We look at the customer requirements and the stories, etc. We implement the IAST analysis of use case tests and code reviews. We break the build and do some code analysis, see what happens. We do common abuse cases. We look at pen testing, compliance validation, PCI, etc., and fuzzing. Fuzzing is where you take like a user interface or something in an application and you put in a wide range of junk until you try to break it by kind of like overloading it with junk. Configuration deployment, we look at configuration validation and feature toggle traffic shaping. On monitoring, we look at log information for after incident analysis or even active alerting and alarming. We have detect, which is intrusion detection and app attack detection. In the containment, we use RASP and rollback or toggle off. And we block attackers and we shut down services. With the stabilize, we restore and maintain services for non-attack usage. And then we analyze. We look at root causes or FMEA analysis. Is there a new attack surface? We have to plan to update our threat model. So this is kind of how we think through all of these different phases of the DevOps cycle and our security input or overlay to it. The ecosystem of DevSecOps. There are different phases in the DevSecOps ecosystem, and security scanning is included throughout that ecosystem. The phases in the DevSecOps ecosystem are as follows. We have development, version control, pre-build, post-build, QA, staging, production, and monitoring. With development, we're doing the IDE plugins. We're doing pre-commit hooks. We're setting third-party component scanning. Pre-commit hooks are interruptions before you hit the big dreaded enter key and your code gets dropped in the library as the updated version, by the way. Speaking of version control, we look at repository scanning and security management. On the pre-build, we do the static application security test. Post-build, we do dynamic security testing. We also look at container and cloud security. We start bringing in this infrastructure to look at the environment that this is going to go into. Quality assurance gives us a chance to do more security testing and third-party component scanning. In the staging side, we have vulnerability testing and penetration testing that occurs. In production, we look at securing infrastructure as a service, cloud as a service, and security as a service. And then over in the monitoring, it's up in production. We do security monitoring and alerting. So within each one of these phases of this continuous integration, continuous development pipeline, we have the opportunity to build in security. Now I'm going to back up real quick and just say that you don't do this all at once. This is what you're going to for a mature model. If you're just starting out, you go with the highest risk, highest impact that you can make on the DevSecOps effort. Key elements of the DevSecOps pipeline. To ensure that security is integrated in the DevSecOps pipeline, every organization should perform the following checks. Pre-commit checks. These checks are performed to detect and remediate common security issues before committing any changes to the source code repository. It's also called setting hooks. We have commit time checks. And these checks are performed automatically on the code repository. The checks provide fast results for changes that have already been committed to the source code repository by developers. Then we have build time checks that we insert. These checks stop the build process during SAST failures, failed unit tests, and discovered vulnerabilities, such as SQL injection attack capabilities or cross-site scripting. And we have test time checks. After the successful build time checks are accomplished, test time checks are automatically performed. In this stage, advanced checks are performed to detect critical and high severity issues using dynamic testing tools and fuzzing and things like that. And then at the deploy side, these checks help identify vulnerabilities that might be missed in the pre-production testing activities. And on the right, you can see a graphic representation of what we just talked about with the CI/CD pipeline and the pre-commit checks, the commit time, build time checks, test time checks, and deploy time checks. Integrating security in the DevOps pipeline. Security can be integrated in the DevOps pipeline through the following stages. We have build, Artifactory deployment, staging setup, staging deploy, UAT tests, production setup, production deploy approvals, and the production deployment. This is a general kind of a flow. And within it, we can insert our security. We have to build the Artifactory deployment. And in between the Artifactory deployment and the staging setup, we can do some static testing and basically kind of like trying to find bugs and things like that within the initial code. Then we have the staging setup, staging deploy, and the UAT test. In between the UAT test and production setup, we can go ahead and run some dynamic testing, looking at like OWASP Zap as a tool to run there. In between the production setup and the production deployment, we can do infrastructure scans, compliance scans, and look at OpenVAS. Now, OpenVAS is a comprehensive vulnerability assessment system that can detect security issues in servers and network devices, basically. So it kind of ties in with that infrastructure piece of the scan. We get into the production deployment and production deploy, and then we look at the WAF deployment as another integration that can occur within this DevOps pipeline. So within stage one, we have static application security testing that can be done. And basically, it's here represented in that red box in the diagram. At this stage, the DevSecOps team uses SAST, an automated code review tool, to detect simple vulnerabilities in the code, such as insecure libraries, SQL injection vulnerabilities, or cross-site scripting issues. As we move into the pipeline in stage two, we start looking at dynamic application security testing. In this stage, the DevSecOps team detects deployment-specific security issues. The results obtained from SAST and DAS tools should be compared to remove false positives so that we can take the true positives and put them into a workflow structure. All right, so then we have stage three where we do infrastructure scans. In an infrastructure scan, the base image is scanned for vulnerabilities. The OpenVAS tool is used typically for vulnerability assessments. Then we come to stage four, the compliance scans. Compliance is a set of rules that we all have to adhere to, either created by regulators externally or by internal rules that exist. And we convert these rules into written test cases. You can use something like the inspect tool for performing a compliance scan in the environment. Stage five, we talked about the WAF deployment. A web application firewall is deployed to protect the application from threats. Implementing security into the CI/CD pipeline. The security posture must be evaluated at the early stages of the software development lifecycle to find and fix vulnerabilities quickly. We've been saying this for years, of course. To implement security in the CI/CD pipeline, organizations use tools such as SAST, DAST, RASP, and IAST, like we've talked about. The alerts created by these tools should be correlated by deploying tools such as SIEM. So you can take these tools and have their outputs fed into a SIEM if you have one on-prem or if you use one. You can use one in the cloud, actually. But if you do use a SIEM, the bottom line is you can take WAF, RASP, IAST, and SCA, etc., pieces of this, and drop the output in the SIEM to create alerts and alarms to the security organization so you can investigate what's going on and possibly lean in if it's in the earlier build and test side or the acceptance prior to accepting and deploying, and certainly to remediate issues in production environments with the SIEM alert. Security controls. Various security controls can be applied at different phases of DevSecOps to ensure that the DevSecOps pipeline is safe from attacks. In the pre-commit, we look at threat modeling. And there are threat modeling tools that are great out there that we'll discuss in a little bit. There's the IDE security plugins, pre-commit hooks that can be used to run scans prior to committing code to libraries. Then you can also do peer reviews, peer code reviews. That's actually kind of a fun exercise. You can create internal bug bounty exercises if you've matured your program far enough along. Then you have the commit. You look at static code analysis and security unit tests, container security again, with the microenvironments that you need to protect, and dependency management between different chunks of code and environments, etc. Once you get into the acceptance of what's been built, you do infrastructure scanning, dynamic security tests. You look at the cloud infrastructure, assure that your templates and all the security controls have been applied there. And you have security acceptance tests that occur as a part of that release cycle. In production, you're looking at security smoke tests. Is this thing working or not? Are there some issues here? Are we seeing odd behaviors? You look at security configurations. Secrets management is critical as you move to production, with pieces of code validating back and forth, or functions having to validate across this infrastructure that you've created. Then you also look at server hardening and environment hardening that gets accomplished as part of that production run. Now, once it's up in operations, and if you discover issues, you do the continuous monitoring. And if, like I said, if you discover issues, you want blameless postmortems that you can run with the organization. There's the old Japanese saying, I think, that says, fix the problem, not the blame. And that's what blameless postmortems are about. You're trying to fix problems if you discover something wrong. And up here, you also do penetration testing, and you apply threat analysis and threat intelligence to the environment. Take external sources of threat information and apply it to the operation of your applications in the environment. We'll get into more on that later as well. So let's start into some of the cloud-based pipeline architectures for DevSecOps. And as you kind of look through this, and you can see how the code flows and it ends up in production over on the Elastic Beanstalk, we see all these things like parameter store and CloudWatch events or Lambda. What are these items? And so I'm just going to kind of walk through, and we'll spend a little bit of time on this, but just walk through what these blocks and pieces are in this workflow. AWS Code Build compiles source code, runs tests, and produces software packages that are ready to deploy. The code commit. This is source control. It's a service that hosts like secure-based, Git-based repositories. Code deploy automates software deployment to a variety of different compute services that are available up in the AWS environment. Code pipeline automates your release pipelines for fast and reliable application and infrastructure updates. Lambda is a service that lets you run code without provisioning or managing servers. This is the one that makes sure that you're only paying for the services that you need at the time that you consume them. Amazon Simple Notification Service. This is a messaging service for both application to application and application to person communications. The Simple Storage Service is think of this as your S3 buckets. It's down in the green box towards the left. These are your storage buckets, basically, for the internet. And then you have the Systems Manager and Parameter Store up on the upper right in black. This gives you visibility and control of your infrastructure on AWS. Lets you see at any given time what you're actually consuming. Now, as far as the continuous testing tools that are used here, we look at those, and we have the OWASP dependency check. This is a software composition analysis, SCA tool, that attempts to detect publicly disclosed vulnerabilities contained within a project's dependencies. You have SonarQube, which is a static analyzer, a static application test. This is an automated static code analysis. It's based on rule sets, et cetera, that you program it with. PHP Stan is a SAS tool that focuses on finding errors in your code without actually running it. And then we have OWASP Zap, and we'll talk about OWASP Zap a little bit further along as well. But it helps you to automatically find security vulnerabilities in your web applications while you're developing and testing them. So it's a fairly robust test method or capability. Now you also have AWS CloudWatch logs. They allow you to monitor, store, and access your log files from those the Elastic instances. Over on the left, you see the 3 yellow boxes. This is your auditing and governance kind of overlay to this entire pipeline. You have AWS CloudTrail. This enables governance, compliance, and operational auditing and risk auditing within this whole AWS environment. You have identity and access management. This enables you to manage access to services and resources within this environment securely. With IAM, you can create and manage the users, the groups, permissions, and allow and deny their access to different resources. Then you have AWS Config. This allows you to assess, audit, and evaluate the configurations of your AWS resources. And typically when you buy into, if you bought into some of the cloud services, you should look at what's provided for free by them as far as these security tools, governance tools, scanning tools, et cetera, within the infrastructure. On the operations service on the far side, you see staging with Elastic Beanstalk. And basically, Elastic Beanstalk is a service for deploying and scaling web applications and services that are developed with things like .NET, PHP, Java, Python, Ruby, and Docker. And this allows all of these web apps to be deployed on familiar servers such as Apache, Passenger, IIS, etc., rather easily. So this is just the general flow that you can see with the AWS architecture. And of course, Azure came up with theirs as well. In Azure, we're going to walk through this a little bit because it's much more of a flow instead of a product-specific kind of a view. So we start off with Azure Directory, Active Directory. It can be configured as the identity provider for GitHub. Multi-factor authentication can be enabled for extra security within it. And we're starting out kind of on the far left with this. The developer commits to GitHub Enterprise, driven by work items and bugs tracked with Azure boards. GitHub Enterprise can integrate automatic security and dependency scanning through GitHub Advanced Security and GitHub Open Source Security. A pull request triggers the CI builds and automated testing in the Azure pipelines. At step 5, the CI build in Azure pipelines generates a Docker container image that's stored to the Azure Container Registry. And that's going to be used at release time by the Azure Kubernetes service. Upon uploading the Azure Container Registry, Microsoft Defender for Cloud will scan the image for Azure Active native vulnerabilities and security recommendations will be given for that pushed image. Then at 7, we have the release on Azure Pipelines, and it integrates using the Terraform tool, managing both the cloud and infrastructure as code, provisioning resources such as the Azure Kubernetes Service, the Application Gateway, and the Azure Cosmos DB. Azure Pipelines enable continuous delivery to the Azure Kubernetes Service by accessing the container registry through the security service connections. Azure policy can be applied to Azure Pipelines to enforce post-deployment gateways and can be applied directly to the AKS engine for policy enforcement. Now we have the Key Vault, which is used to securely inject secrets and credentials into an application at runtime. And basically, one thing about key and secrets management I didn't really mention is the big deal with them is they actually apply, they abstract this information and keep it away from developers and other individuals. So it's actually kind of a protection of it. And this gives you your policy enforcement. So the end users can authenticate with Azure AD B2C, which is business customer or client. And it's required, and you can put in requirements to use MFA for extra security. You can be routed through the application gateway. That can be load balanced to protect core services, etc. Then you have continuous monitoring with the Azure Monitor. It extends to the release pipelines and to the gate, or provides rollback releases based on the monitoring of data. It also ingests security logs and can alert on suspicious activity. And it can also export those logs to your SIEM solution if you'd so prefer it. As a final part of this whole DevSecOps flow, Microsoft Defender for Cloud will be able to do the active threat monitoring on the Azure Kubernetes service on both the node level, the VM threats, and the internal operations and actions. So you have the Azure Active Directory, basically, which provides the identity and access and management services. Source code is hosted on the GitHub Enterprise, where developers can collaborate within your organization. You have Azure boards. This is used to plan work and track progress. You have Azure pipelines that can be used. They provide continuous integration and delivery of jobs to build and release applications automatically. The container registry provides container image scanning with all the integration with Microsoft Defender Cloud. The Kubernetes services offers Kubernetes cluster that is managed by Azure. Terraform allows infrastructure automation on Azure as well as other environments. Policy lets you create, assign, and manage policies. You have the Key Vault. We talked about that. The Azure Cosmos DB is compatible with multiple APIs, including like MongoDB, Cassandra, and SQL. The Application Gateway is a Layer 7 load balancer with support for advanced routing rules and web application firewall integration and use. Then you have the ADB2C. This is identity services for consumers or people outside of your organization. So it's a pretty holistic approach that they use. You have a lot of tools that are available to you as a security professional, a lot of services, etc. So, like I said before, if you're looking at AWS or Azure, see what's integrated in the purchase or what can be added to the purchase to provide these higher levels of security throughout the entire flow of the CI/CD pipeline. In this next lesson objective, we're going to understand DevSecOps strategy. How do we go about deploying this? What are we going to look at as far as getting this organization to change from a DevOps into a DevSecOps type of organization? There's a need for DevSecOps strategy, obviously. Virtual environments are evolving, and the enterprises that adopt to the DevOps methodology are moving to the cloud since it offers scalability and flexibility for an on-demand resource type of pool. Next generation applications developed using the DevOps methodology are migrated to a cloud environment, and these applications could have several security issues that range from bad code to misconfigured servers. We'll talk about technical debt and security debt in a bit. But the DevOps strategy efficiently and effectively resolves these issues and holds everyone accountable for the security of the software from the beginning of the development cycle to the very end. And so if you're having a lift and shift to the cloud, look at what kind of security debt you're going to move to the cloud. Things will follow you there. And when you develop your strategy for implementing DevSecOps, and if it's because you are moving to the cloud, make sure you understand the environments and exactly how this is going to transform from the on-prem or in your managed services environment up to a cloud platform. Implementing an effective DevOps strategy. Implementing an effective DevSecOps strategy. The DevSecOps strategy focuses on security from the beginning and continues to focus on it throughout the entire software development lifecycle. It's a complex process that uses the following for effective implementation. You have to educate the team about the DevSecOps security best practices and explain everyone's roles and responsibilities in supporting it. You have to allow developers to learn. They're very creative by nature, and by training the developers, you allow them to implement the DevSecOps into their code. You provide the required tools to developers so that they can succeed in their tasks and contribute to the successful delivery of secure software. Conduct audits and security assessments. Audits and security assessments are a great way of identifying the existing vulnerabilities or flaws and remediating them. And you can also use this same approach when you look at the overall DevSecOps flow and pipeline. Look at doing audits and security on the processes, where it's injected into the processes, etc. You can enable code-based security. From the beginning of the DevSecOps pipeline, developers should develop code using best practices. And automation. This is central to DevSecOps. You implement automation to perform repetitive and time-consuming tasks. This could enable teams to focus more on the quality of the software from the business perspective and remove the security burden, or at least ease it quite a bit. There's a need for change in management strategy. In DevSecOps, different people work collaboratively on systems to perform different operations, such as writing new code, changing network configurations, and running tests to ensure security in all phases of the software development lifecycle. For a successful implementation of change management, it is crucial to determine how changes can be managed, what techniques and methodologies can be used. A change management strategy is important for the DevSecOps principle, as it ensures that the developers, security team, and operations team can handle system configurations and make code changes faster and easier. It also helps with fixing security incidents faster because you know what's in the environment. You have this record of change and what's going on in there and what's been deployed. Change management strategies. For the successful implementation of change management, use the following strategies. Use Agile and DevOps principles such as automation, using rules and thresholds that can reduce human errors. Use a change advisory board or a CAB that provides support for change management by approving requests and by assessing and prioritizing changes. Integrate with existing tools and processes such as the use of JIRA tickets to send emails for requesting change approvals, along with summaries and other information that's required to be able to make those decisions. Plan the release of changes early and avoid adding additional processes. For example, plan in advance for the mechanisms to be used for implementing changes effectively. To reduce the negative impact of change, prepare for failures and incidents using monitoring tools that can send an alert when a failure occurs. Perform continuous improvement, analyzing the results, mitigating internal issues, as well as the issues reported by customers. Couple of things, last things to mention. There's actually a DevSecOps maturity model that represents the security measures while using DevOps strategies. It also represents how the DevOps strategies can be prioritized. Using DSOM, it helps your organization have the proper principles and measures that have to be implemented if a security breach occurs. So there's broad-reaching implications with looking at a DSOM model and applying it to your DevSecOps program. There are 4 evaluation criteria within the DSOM model. You have static depth, and this determines the level of detail of the static code scans that are performed in the application security and CI/CD pipeline. The dynamic depth determines the efficiency of dynamic scans performed in that pipeline. The intensity, it looks at the frequency of scans that are scheduled in the application security pipeline. And finally, consolidation. It measures the workflow of remediations for handling findings. What do you do once you find problems? So these are the 4 kind of major pieces that are evaluated with the DSOM model. And finally, lesson 7, understanding the DevSecOps tools. DevSecOps enables developers to make continuous testing a kind of a default or a automated task. It also allows security teams to deliver safe software features more quickly. Many solutions and technologies are required to integrate DevSecOps culture into an organization without creating gaps in security. Various tools are commercially available. You also have free tools out there that you can use. Organizations can choose security tools that work best for them. These security tools play a major role in the detection of security vulnerabilities. So if we look at the DevSecOps pipeline, we have source code, the CI server, test and scan artifacts, deploy, and monitoring as the big phases. So going down through left to right, on the DevOps pipeline, we see the tools that they use: Azure Repos, GitHub, Bitbucket, Jenkins, Cucumber, Selenium, Maven, Nexus, Frog Artifactory, Puppet, Chef, Terraform, etc., all the way through to Splunk at the end of it. On the DevSecOps pipeline, we look at some of the specific tools that are used from the security perspective to enable the safe migration across this diagram. Left to, and we tend to try to push them. The reason the arrow is going left is that we tend to try to push this stuff earlier into the cycle. The whole thing with DevSecOps is early detection and remediation of problems. That's why we're doing this. So over on the left, we see SonarQube, Fortified Veracode, Tenable IO, Gauntlet, no WASP, Frog X-Ray, UpGuard, Nessus, Splunk, UpGuard, and Catchpoint. We'll discuss these tools in a little bit of detail on how to integrate them into the DevSecOps program in later modules. So here's kind of a quick summary of the DevSecOps tools that are used for on-premise environments typically. Threat modeling tools use OWASP Dragon, Threat Modeler, Yakundi, Threat Playbook, Raindance, PyTM, etc. Pre-commit hooks, which is just before you go ahead and hit enter and drop your code in the library. You can run scans using Talisman, get secrets, pre-commit, detect secrets, etc. The software composition analysis tools include RubySec, Retired.js, Requires IO, and Repo Supervisor. Static analyzers include things like Bandit, Brakeman, CodeSignon, Find Bugs, PMD, Clockwork. IDE plugins, security tools there are DevSkim, JFrog, Eclipse, Snyk, Cat.net, Spotbugs, etc. For secrets management, you have HashiCorp Vault, Taurus, KeyWiz, and NVKey, Confident, and Doppler, and Burglass. And secrets management, again, we're talking about on-prem. The cloud environments have their own secrets management capabilities. For vulnerability management, Archery Sec, Defect Dojo, Jackhammer, ThreadFix, Qualys, Falcon, Vulnerability Manager Plus, Kena Security, things like that. For dynamic testing, there's Arachne, Acunetics, Fortify, Web Inspect, Veracode, Dynamic Analysis, Sentinel, etc. So security and infrastructure as code. Some of the products include Claire, Anchor Engine, Dagda, OpenSCAP, DocScan, Snyk, etc. For compliance as code, there's InSpec, ServerSpec, DevSec Hardening Framework, Kitchen CI, Docker Bench for security, and finally Web Application Firewall. You have Mod Security, WAF, Naxi, WebNight, Shadow Daemon, and Perva, things like that. When we talk about cloud environments, there's different tool sets that we start looking at. For example, up in AWS for the threat modeling tools, you can integrate or use native tools. Threat modeling tools include Arius Risk, AWS Threat Model, and Foresee It. Pre-commit hooks, you look at Git hooks. For software composition analysis, there's the OWASP dependency check, Snyk, White Source, and Black Duck. For static analysis security testing, LGTM, SonarQubes are very popular, and Veracode, Checkmarks, and SpectralOps. For IDE plugin analysis, Snyk. For secrets management, you can integrate others, the HashiCorp Vault, or use AWS Secrets Manager, or integrate Doppler. For vulnerability management, you can use Archery Sec, ThreadFix, Qualys Rapid7 Insight VM, Falcon Spotlight, or the Vulnerability Manager Plus. For dynamic application security testing, think of NetSparker, Portsware, Tenable IO. Security and infrastructure as a code, Claire, again, Anchor Engine, OpenSCAP, Cloudsploit, Accurix, and Tflint. Compliance and code. Compliance as code, the products include Inspect and Kitchen CI. We'll talk about that as we talk about the Chef Suite a little bit. After bit. Web app firewalls, AWS WAF, Imperva, Barracuda, or Citrix can be used. If we look at Azure, they have theirs as well. There's native and or integrations that you can do. For the threat modeling tools, there's Arius Risk and Microsoft Threat Modeling Tool, or Foresee. Pre-commit hooks, Azure Webhooks, software composition analysis, OWASP again. You can go with Sonatype, Snyk, White Source, and Black Duck. These were all on the last three were on the previous AWS use tools that you could use as well. For static analysis, security testing, LGTM, SonarQube, PumaScan, Veracode, SpectralOps, HCL, AppScan, Fortify, and Coventry. For IDE plugins, again, SNCC with DevSkin. Secrets management, you can use the Microsoft Azure Key Vault or HashiCorp, Confident, and Doppler. For vulnerability management, Qualys again, Flexera, Rapid7, Insight VM again, Falcon, etc. And one thing is that some of these tools work in multiple cloud infrastructure and environments, AWS, Azure, as you can see here. For dynamic application security testing, ZAP, NetSparker, Detectify, PortSwigger, AppCheck, AppNox, and Tenable. Security and infrastructure as a code, Anchor Engine, CloudSploit, Accurix, Checkov, and DFlint. Compliance as code, you can use Inspect, Kitchen CI again, and web application firewalls. There's Mod Security, Azure Web Application Firewall, Barracuda, and Single Sciences WAF. So let's go through a summary of the module. Developers, operation executives, and security professionals have to work together throughout the development lifecycle to implement a secure DevOps program. DevSecOps is an integration of security practices into the software delivery model of DevOps. It's an overlay that gets pressed in. The goal of DevSecOps is to incorporate security in all the phases of the software development lifecycle by integrating security through tools, encouraging cross-skilling, and establishing security as a code culture. Try to follow the high-value DevSecOps metrics of the U.S. General Service Administrator, GSA, to measure the successful implementation of DevSecOps. The key security behaviors that an organization should instill into the DevSecOps team are threat modeling, secure code reviews, and red teaming. Continuous delivery and continuous integration allows developers to validate and report every code commit in the software product. There are different phases in the DevSecOps ecosystem, and security scanning is included throughout the entire ecosystem. Every organization should perform pre-commit, commit time, build time, test time, and deploy time checks to ensure that security is integrated in the DevSecOps pipeline. Organizations use a wide range of security tools such as SAST, DASP, RASP, and IAST to implement security in the CI/CD pipeline. A change management strategy is very important for DevSecOps as it ensures that the development teams, the security team, and the operation teams can handle system configurations and make code changes or even environment changes quickly and easily. So this pretty much wraps up this module. Thank you for paying attention, and I'll see you in Module 3.